How can you write a number using exponents? The expression 2 times 2 times 2 represents the number of cells after 1 hour if there is one cell at the start. How can you write this expression using exponents? How many cells will there be after 1 hour?
An exponent is a way to write a repeated multiplication expression.
You can use an exponent to write repeated multiplication of a number. Exponents are useful because they can shorten expressions that show repeated multiplication. The number that is repeatedly multiplied is the base. The exponent tells how many times the base is used as a factor. A number that can be written using exponents is called a power. You can use repeated multiplication to evaluate or find the value of a power. Multiply the first two factors. 2 times 2 equals 4. Then multiply that product by the last factor. 4 times 2 equals 8. 2 to the third power equals 2 times 2 times 2 equals 8. There will be 8 cells after 1 hour. Now you know how to write a number using exponents.
There are 2 times 2 times 2 times 2 times 2 bacteria cells after 100 minutes. Write the repeated multiplication as a power and then evaluate.
So let's take a look and evaluate 2 to the power, we have to make it a power. So we have 2 as our base and we have 1, 2, 3, 4, 5. So then that is our way of writing it as a power, 2 to the 5th power. And then we have to evaluate, which means to solve it. So we have to do 2 times 2. And then let me do a different color. Green. 2 times 2 is 4. And then 4 times 2 is 8. And then 8 times 2 is 16. 16 times 2 is 32. So that is equal to 32. And we're done.
Part A. How can you evaluate -2 to the 0 power?
The base is -2. The exponent is 0. Make a table and look for a pattern. -2 to the power of 1 is -2. -2 to the power of 2 is 4. -2 to the power of 3 is -8. And -2 to the 4th power is 16. Each value equals the previous value multiplied by -2. So -2 to the power of 1 is equal to -2, and -2 divided by -2 is equal to 1. So the value before -2 to the power of 1 is 1. Therefore, -2 to the power of 0 is equal to -1. Any non-zero number with an exponent of 0 has the value of 1. No matter what the base, as long as it's not 0, it is going to be a value of 1.
Part B. How can you evaluate 1 2/10 to the 4th power?
So let's take a look. The base is 1 2/10. The exponent is 4. So you're finding 1 2/10 times 1 2/10 times 1 2/10 times 1 2/10. And multiply the first two factors. You get 1 44/100 times the next factor, which is 1 2/10. And then you get 1 728/100 times 1 2/10. And then you multiply that and you get 2 736 10,000ths is the value of 1 2/10 to the power of 4. And then this is on a chart, exactly what we did here. They're just showing it in a table. Now we have to evaluate each exponent. So I'm going to do each one of them because they're all different. The first one is with fractions. So let's take a look. So 1/3 times 1/3 times 1/3. So we multiply the first two, and that is going to be 1 times 1 is 1, 3 times 3 is 9 because we're multiplying straight across. Now we do 1/9 times 1/3. 1 times 1 is 1, 9 times 3 is 27. So that answer would be 1/27. 1/27. Now let's look at B. B is -5 to the power of 3. So we have -5 times -5 times -5. And so we do the first two, -5 times -5, which is going to be positive 25. And then 25 times -5 is going to be negative 125. And that's it. Now let's look at C, 1 3/10 times to the 5th power. And so let's write this one out. Alright, so we have 1 3/10 times 1 3/10 times 1 3/10 times 1 3/10 times 1 3/10. Okay, so we have to start by multiplying the first two together. So 1 3/10 times 1 3/10. I'm going to write my work over here on the side. So we multiply it. 3 times 3 is 9. 3 times 1 is 3. 1 times 3 is 3. 1 times 1 is 1. Add it up. We have 9, 6, 1. We have 1 decimal place here, 1 decimal place there. So we need 2 decimal places in our answer. So it'll be 1 69/100. Now we're going to multiply that by the third 1 3/10. Erase my work. Alright, so now we have 1 69/100 times 1/3. And remember, with multiplying decimals, they do not have to line up. The decimals do not. So we're just multiplying. 9 times 3 is 27. 3 times 6 is 18, plus 2 is 20. Then we have 3 times 1 is 3, plus 2 is 5. 1 times 9 is 9. 1 times 6 is 6. 1 times 1 is 1. Then we add that up. We have 7, 9, 11, and 2. So we have 2 decimal places here, 1 here. So in our answer, we need 3. So we have 3 there. So now we have 2 and 197 thousandths times the fourth 1/3. So we're going to show that work. Erase this. All right. Now 1/3 times, let's write 2 and 197 times 1/3. Okay, so we have 7 times 3 is 21. 9 times 3 is 27, plus 2 is 29. 3 times 1 is 3, plus 2 is 5. 3 times 2 is 6. 1 times 7 is 7. 1 times 9 is 9. 1 times 1 is 1. 1 times 2 is 2. Add that up. We got 1. 9 times 7 is 16. And then 9 times 5 plus 1 is 15. And then 1 plus 6 plus 1, 8. And then 2. We have 3 decimal places here, 1 here. So we need 4 in our answer. So decimal goes here. So we have 2.8561. And now we have to multiply it by our last 1 3/10. Let me erase my work. So this is not hard, it's just very time consuming when you have decimals sometimes to a very high power. So let's keep going. Let's do it in black. Okay, so we have 2.8561 times 1 and 3/10. We have 3, 18. 3 times 5 is 15 plus 1 is 16. 3 times 2 is 6 plus 1 is 7. 1 times 1 is 1. Wait, did I skip something? I feel like I did. Let's start over. Okay, 3 times 1 is 3. 3 times 6 is 18. Put 8 here. 3 times 5 is 15. Plus 1 is 16. 8 times 3 is 24. Plus 1 is 25. 3 times 2 is 6. Plus 2 is 9. I did skip 1. Alright, 1 times 1 is 1. 1 times 6 is 6. 1 times 5 is 5. 1 times 8 is 8. 1 times 2 is 2. Now we add this all up. We have 3, 9, 12, 11, 10, 18, and 3. And we have 4 decimal places here, 1 here. So we need a total of 5. So 1, 2, 3, 4, 5. Our decimal goes here. So this would be our final answer, 3.81293. And always when you have a lot of multiplication like that, check your work. And let's see, I'm using a calculator. And I got, I was actually off. My correct answer was 3.71293. So somewhere in here I was off by 1. That happens. So always check yourself, especially when you're doing so much, you can always skip a step. Alright, so that is all of these.
Julia calculated the foil as 1 9/10 times 10 to the 5th power units thick. Tom calculated the foil as 183,000 units thick. Which calculation represents the greater thickness for the foil?
So we evaluate 1 9/10 times 10 to the 5th power. They show us in this table the powers of 10 and their value. When we get to the power 5, they show us it equals 100,000. And then we multiply that times the 1 9/10 and we get 190,000. And then because it asks us which calculation represents the greater thickness, what Tom had or what Julia had, Julia had the 190 and Tom had the 183,000, and so 190 is greater than Julia's is greater than Tom's calculation. Now let's look at the try it.
Raphael calculated the foil as 1 8/10 times 10 to the power of 4 units thick. Evaluate Raphael's expression.
Alright, so perfectly for us, we have in our previous example the value of 10 to the 4th power on that table. So 10 to the 4th power is 10,000. So we are going to just use that and then multiply it by the 1 8/10. And so you would write it, I'm going to write it vertically as well so we can, multiply it. Alrighty, so we have 4 zeros. I'm just going to drop those down there because all that's going to equal 0. Then 8 times 1 is 8, and then it's going to be 4 zeros for the 1, and then 1 times 1 is 1. Add that up, 0, 0, 0, 0, 8, 1. and then we have 1 decimal place. So we need 1 in our answer. That would be here. So we have 18,000 as our final answer for Raphael's expression. And so his is 18,000 units